you imagine walking along and suddenly appearing behind a wall? Well, this might be impossible in our real world, or at least for classical physics. Let's move to the world of quantum physics. Here we can find a fascinating phenomenon where the smallest particles, let's use a simple electron, find shortcuts to overcome barriers without breaking them. But how can electrons do this? Let's say they aren't exactly tiny balls, like Bohr's atomic model. They are more like a wave, spreading across different locations at the same time with different probabilities to appear. What does this mean? Well, our electron cannot be found at a fixed place. They could be right here or right there. And just because its properties as a wave, the higher the frequency, the more likely the electron might appear, or vice versa. When the wave has no frequency, then it's impossible to find the electron. As an extra piece of information, this atom model was proposed by Erwin Schrödinger. Yeah, the guy from the half-alive, half-dead cat theory. So, until I measure it, the electron will appear in some position which is more prevalent in certain places than in others. This forces the electron to define its location, either a very probable one or a very rare one. Let's bring back the barrier. The electron wouldn't be able to escape with its energy. However, by performing quantum calculations, there's a small chance it will appear on the other side. This phenomenon isn't just a theory. It actually happens all the time in nature. For instance, nuclear fusion takes place in the stars, where hydrogen atoms combine to form helium, producing energy and making the stars shine. Moreover, this phenomenon has contributed to the development of modern technology, such as electrical conductivity in semiconductors, where tunneling allows the control of electron flow. Without quantum tunneling, much of today's technology simply wouldn't work. It's one of those invisible effects that silently power our world. And since we've mentioned semiconductors, let's talk about the transistor, a key component in modern electronics. Actually, the smaller the transistor, the more the tunneling effect becomes noticeable. Sometimes it even causes electrons to leak through barriers. So, from the heart of a shining star to the chip inside your phone. Quantum tunneling is one of the strangest, yet most essential, tricks in the universe.